Am I muted? Well, there you go. There's my mic. Well, howdy, y'all, and welcome to another high-powered episode of the High Voltage Live Show. I'm your host, Willie Snyder from Nat King Code, coming to you from the Mile High City in Denver, Colorado. I am joined by my awesome co-host, Mr. King James Stallcup of the Volt Online Academy, CEO and creator of the High Voltage Live podcast. It was really awesome, all the participation we had this week with Myth of the Week. We've been having a lot of fun. Jumping in with you guys and, just kind of talking code and kind of putting it to a real life situation. I was kind of digging around up in the ceiling, the job site I'm at, trying to see how many lights had ceiling wires on them, and there wasn't very many. Um, but a lot of people says code. Hey, what's up, Mike? Awesome. Thanks for joining us, sir. Um, but it's just been really awesome to have all the participation. We're at 28,000 now in NEC for Dummies. That's really amazing that group's been growing so fast.
God, it'll be 30 before you know it. That's just unbelievable.
Yeah, it seems like just not too long ago we did our 20K one,
Yeah.
which as that was a really good show. If you guys want, you can jump in. You can subscribe. You can hit the likes. It really helps out the channel, and it's really awesome for us to be bringing you guys these fun topics every week. And I don't know if this was a good or bad thing this week, James, but I actually let you decide. I let you choose the meme. So I know everyone knows I'm always like meme crazy with all the memes that I got, but I know you had a pretty good one for us this week. So
Yeah, this is I remember when we started the meme group, I actually did like 3 or 4 memes, but being an electrician, and especially apprentice, exactly what you went through.
oh,
Uh,
awesome. Mark Candel's welcome in, sir.
hey,
Yeah.
Mark.
We're gonna have to
Uh,
have you on. You do better running the show than I do.
but they when I put it together, I was thinking about it, and I thought every journeyman and apprentice can relate to this meme, and so I was like, I'm going to do the meme this week. So
All
here you
right.
go. Here's my meme of the week.
Check it out. Yeah, that's always funny every time. I always try to give them hints and stuff. I'm like, is it the one with the pink handles? And I always say, oh yeah, is it the left-handed one or the right-handed one? And they're always like, oh, I don't know. I'm gonna go ask. And the foreman's like, dude, did he come ask if it was the left-handed one? Serious?
I, I'll tell you a story on that. It's the reason I really like that. And, I've been doing electrical work since I was 14. My grandfather,
There you go, Mark. Awesome.
hey, brother, uh, he, my grandfather was a contractor. And so, I'd worked with my dad, my uncle, they pulled all them tricks on me. And when I got out after high school, I went down. I was working on one of the high rises in downtown Fort Worth, and one of the guys he told me to go get a wire stretcher, and I was like, huh, okay. So I just took the elevator down, and I went over to the roach coach, got me something to drink, something to eat, and I was sitting there eating, and I looked over, and they were putting up this fencing around, and they had this uh, uh, machine over there where they put it down on the end and it would take and pull that fence to tighten it up. And I went over to them. I said, hey, I said, my journeyman, said, they think I'm just a dumbass grunt. And I said, I've been doing this a long time. I was telling them, I said, can we take that upstairs? And they go, oh, hell yeah. So we got the elevator, take it upstairs. And I said, hey, I said, I couldn't find one of our own. I said, but I saw theirs. So I figured this would work just as well. And I started laughing. They didn't send me to go get anything else, but then, then later they'd go get another press. I'd just shake my head. He'd be looking for an hour and a half or so. They'd tell him to go get a sky hook and all this. I mean, and those apprentices didn't know, but I came up to, since I was 14, I'd already been through all that stuff when I was
Right.
a freaking teenager, So Uh,
I'm gonna have to maybe do the meme next week because we one of my apprentices he was pretty smart like you and he actually found a sky hook and it was funny because I didn't tell him to go get it or anything, but I was like, yeah, one of these days, when we're on one of these jobs, you gotta be looking out. We're gonna need a sky hook. And so then it was funny. All of a sudden, he saw it. Some of the guys are doing. I guess it hangs insulation on those metal buildings.
yeah.
And he comes over. He goes, "Hey, I found 80 of them," and it was so funny. I took a picture of it and just gave him a hard time about it, but it was a lot of fun.
You got
Um,
to appreciate an apprentice that has a sense of imagination.
oh yeah, Mike knows about this one. Uh, we always do this like when we're on like demo jobs, and
You
you
like,
get the apprentice, and you say, "Hey man," and you get one of them U lamps,
uh-huh.
and you're like, "Hey man, it takes a little bit of work, but you're gonna get the skill. Eventually, you can make your own U lamps."
Got to bend
So,
it.
and you go take a T8, give him a torch, give him a bender, and then you put like a tarp down and everything. Like, yeah, dude, we know you're gonna break some, but just don't worry, man, you'll get it. And we'll just have them in there, and they'll sit there in there just breaking one after the other. After they're in about a pile of glass, you're like, okay, dude, I'm just letting you know it's impossible, bro. We're just messing with you.
You know what's funny is the reason I know electricians get this is because we're already getting comments on it. So
Oh
they're like,
yeah.
"What about this? What about this?"
Oh, awesome, Mike Barr in the house.
Hey,
Right
Mike,
on. Welcome in, brother.
we'll be having you back on soon, and Mark.
Yeah.
Uh, it
Yeah,
it
we could
won't be
have
long.
we could have both of them on at the same time, and then Mark could just run the show, and Mike could do his stuff.
Mark likes it.
Yeah, yeah, Mark does a good job. It's always awesome having him on here. But yeah, so we have like so many tricks. A lot of them back in the day, I was telling everyone like when I first was coming up, when I was a first year, I used to remember they'd come in and they'd take a little chunk of fish tape and they'd cut it off like maybe about 5-6 foot of fish tape and you'd be sitting there working on a panel or something, and they'd come run up and slap the live bus bars and freaking get the freaking little beads of the fish tape rolling around your
Yeah,
feet and be like, "Oh, you gotta freaking get tough and not get jumpy, when people are sparking and arcing around you, while you're making up a panel because you're gonna be working on them hot." And they were always toughening you up back then when I was a first year.
yeah. I remember the first time I made a panel up. Uh, we, the where the line side come in, it was hot, and my uncle was showing me what to do, and he took and turned all the breakers on. Well, I think I was 14 at the time, and he come over. I had some done. He goes, "You need to tighten those screws up." And he'd tighten it up, and I took and I wasn't that big, so I touched the side of the panel board to where I could do it, and I'd get shocked. And I go over, I said, "That some bitch is shocking me." He goes, "What?" He went over there doing it. "Ah, it ain't shocking me." He goes, "You're imagining." And I do one, I tighten and I touch sides. I just didn't understand, at 14. And finally, he explained it to me, and I said, "Why would you do that?" And he goes, "Well," he said, "because your dad did the same thing to me." Oh, okay. Well, wait till I get Zeb. How about that?
That's funny. We always mess with like the GCs all the time because like a lot of times you'll get some of those GCs that just aren't too smart. And
Mhm.
anytime you get the electricians, Mike knows about this. We always mess with the GCs. Like when it's kind of like blood in the water when all the Sparkies start figuring out the GC's not too bright. We
Mhm.
had one where his layout was wrong, and we were trying to tell him that his tape measure needed calibrated. So we actually got him to go down to the Home Depot to get his tape measure calibrated because we're like, yeah, you got an uncalibrated tape measure. And oh man, we were just sitting there roll laughing. He actually went, it was so funny. But yeah, um, yeah, and Mike's right. That was the old timers back then. They used to just stand on a board, lick their
Oh God,
fingers.
yes. My grandfather was showing me. Mike would. That's funny he brings up because back a long time ago in the code, it used to tell you how to test for voltage, and it'd tell you to lick your forefinger and just pop it like that. and then the funny thing is, it said after you lose the filling in your forefinger, then lick your thumb and do it.
Right.
I mean, that goes to show you, even back in, they knew what it was going to do to your skin, but they'd tell you you'd lose feeling there and wouldn't be able to tell. I mean, uh, but he'd show me his finger and his thumb, and they were just calloused from where he had touched voltage testing it all them years. I thought
Oh
that was
yeah.
funny, but the code used to tell you to test it that way. I mean, that's
I'm
something.
I'm sure. I'm sure Mark knows, and yeah, yeah, you do, Mark. Oh, dude, we're having a blast up in here. Um, and speaking of blast, I had a blast doing the myth of the week. This was really awesome. This is one of the ones that you kind of run into where everyone kind of says, theoretically, you need ceiling wires to support the fixtures, but in all actuality, there's really nothing in the National Electric Code that says that those fixtures need support. We This has been a raging debate over the years, especially when you had the heavier fixtures.
Mhm.
I think one of the building codes back in the day said you had to have ceiling wires on all four corners and stuff like that. And yeah, Mike probably talks about in the late '60s.
Yeah,
Yeah, that's that's incredible, Mike.
Mike's
That's
correct.
hard to believe. But anyway, so this one they always say, and I ran into this a lot. They always say that you don't want the lights falling out of the ceiling. Well, that would be an abnormal condition if a light fell out of a ceiling. So nothing in the code ever really requires you to do something for an abnormal condition. They only require you to install it for a normal condition.
Well,
So
I can tell you what you have to think about, and this is usually where you have a state, city, local amendment, something that's going to take place, and when they require those fixtures to be supported like that, and it's usually due to where they're worrying about seismic activity within a building.
right,
They'll
right.
require it, and they'll do an amendment there to say we want those wires coming down supporting those fixtures. I've actually run into that a couple of times on different jobs I've gone into at different facilities and everything.
All right, so we ready to run the myth?
Sure.
It's time for Myth of the Week.
All right, so the number one heart of this myth is that they say that you have to have these ceiling wires on there so that these lights aren't falling out of the ceiling on firefighters when they're pulling the ceiling down. So that's kind of interesting part. They say that there's going to be a whole bunch of swinging lights of 277 and everything like that. And you can definitely visualize that being a possibility. But I've actually talked with firefighters and they're like, not really. They're like, yeah, usually if we're going to tear a ceiling out to get to a hot spot or something, usually they've either tried to turn the power off or it's already kind of tripped a breaker over there because they're putting a lot of water on it. But there could be the potential that the power's still on, but like I say, it's pretty rare that they basically that was the part that I busted about this myth is that the firefighters really don't really care about if the fixtures are ceiling wired up or not. It's not really for firefighters. I there could be a potential that people were saying they don't want them to blow up with their water pressure because that is the code, which is 41036B, that says they have to either be what we used to do. We used to just sheet metal screw them because we didn't rely on those hurricane clips. You could kind of see that hurricane clip on there. A lot of times what the inspectors would do is they'd come through and they'd push up on them with a broom.
Mm.
And if they could push up on them with a broom, they'd fail your inspection. So we didn't want to mess around with it. We'd just go and just caddy corner sheet metal screw through it. And then we made sure that thing's not moving. And that was all they required. And there was a lot of times where we'd be in certain buildings like schools and certain places where it was like job spec, and that's you always have to go with the job spec. You can't ignore the job spec. It doesn't matter what the code says. If the job spec says do it, you got to do it.
I remember we were doing a job one time, and they actually had us taking drill a hole through up there in Rivetville,
Yeah.
and that's the first time I'd ever riveted pictures in. But that was in the spec; they wanted it in there, so we did it.
Yep. Yeah, it's probably a little extra money, but if you're whoever's sitting there bidding off those plans misses it, then you
Yeah.
guys got to eat it and spend that extra time to do it different.
Well, what I did here is, if you look at this, I have two illustrations that were put together when they started really addressing this in depth, and this was actually in the 1999 National Electrical Code change. This
Okay.
this was actually our illustration back then. So
Okay.
when you get in to look at it, this is where you would go at that time. It was 300-11A1, and they talked about the independent supports and how they were to be identified, and that was showing that they had to be secured at both ends. And that's where you were taking and you were supporting the ceiling grid. And then where you had a box coming down and everything, you would take and have threaded rods coming down to support that. And
Right.
this was a real good example of the securing and supporting when we started looking at our ceiling grid. Now,
I wondered if you were gonna come up with some dinosaur illustration. I
I,
was like, oh man, I was like, this is a good one.
I always have something I can fall back on. We go
Right.
back uh, uh, probably what 35 years that I can go back and look at stuff and see what took place. Well, the next biggest change that came in is they came in was the 2008. So it was
Okay.
almost 10 years when they did it. But what they did, they went in and clarified that the independent supports for electrical wiring, they're permitted to be attached to the assembly.
Okay.
Look at that. And uh, when they did that, what ended up happening? All of a sudden you started seeing that ceiling started getting a wave in it because they were taking using those butterfly clips and it was pulling the ceiling up.
Right.
So we started having problems with that. So that it shows you through the years how things progressed and what they actually allowed you to do. And if you look there, you'll see where we're showing that the uh, if I have independent supports for it, it's fine. And where people got confused was they were taking using the ceiling grid to do that support.
Right.
That was for that's why they had to put the independent support in. And
With the identification,
that's right.
the
And if
311.
you look there on the right hand side of that illustration, we tell you the independent supports have to be what? Identified, but you still
Yeah.
have to secure it at both ends. But you got to make sure when you make that support down on that other end, it's not real tight where it'll cause,
Yeah.
damage to that ceiling.
That's what I was gonna say was we've had times before where I've had to tell guys just to make sure they're just a little bit loose. You don't want them. You don't want to cinch that baby in. I've seen them pull the chopper out of the ceiling before doing that.
Oh,
You
sure.
know.
Sure. And so when you want to clarify this, if you'll go over in the 2023, it's still 300.11, but you're going to look at B1 and B2, and B1 is going to deal with the fire rated assemblies, and B2 is going to be for the non-fire rated assemblies, and
Right.
it's going to give you the information there. Now, what a lot of people they get in and they start looking at this, and then I remember when you were asking me this question, and you had made a comment. Well, somebody was referencing something over in 314. And I said, well, they're probably looking at 314.23D because
Yep.
that's where you deal with your suspended ceilings, and they
Yeah.
talk about D1, the framing members, and then the support wires. Well, if you look at the support wires, where does it refer you back to? 300.11b.
Right.
So here's the correlation, and you've heard me say this many times.
Yeah.
In our publications, we have a lot of NEC loops that refer back and forth to each other. This is a good example of this. So somebody may look at something and don't realize you need to go back and look at the other section, and it tells you that when that enclosure, it tells you it shall be secured, but you have to use what? Identified methods.
Right.
And that's why you go back to 300.11b.
When I do these myth of the weeks, I try to leave our opinions on the curb, and just tell you what the code language says, because like it could be my opinion that these fixtures need to be tied off, or it could be my opinion that they don't need it. I mean, I'm like looking at some of these new LEDs they have out. They're just like a ceiling tile. So to me, I don't see why a listed clip that's listed by the manufacturer to hang in that ceiling, I guarantee those fixtures aren't falling out anymore like they were probably like 20 years ago. 20 years ago, those things had
they were flimsy.
well, like 20 years ago, those fixtures were heavy. Those things were massive. They had 2 T12 ballasts in them or whatnot. So I could see why you would want those things tied up. But when you get to these new ones, the LEDs and stuff now, there's no reason to put ceiling wires on those things.
No, they're light. But that pretty much busts it up for you right there. And those are all the sections. Everything goes with it. I even took you back to when they started adding it to 2 different cycles. And hopefully that helps everybody understand the method.
Yep. So the reference for everybody is 41036B. That basically tells you it has to be listed grid clips or screws or whatever is approved method of attaching the luminaire to the grid, and no wires needed unless the spec says it, but per code.
That is correct. All right. You ready
Sweet.
for the topic this week?
Let's do it.
All right.
Before we get started, I just wanted to say Mike had a thing about securely fastening. So, yeah, you're right, Mike. It needs to be securely fastened to that grid.
That is true.
Go ahead. Right. Sorry about it.
All right, the topic this week, we're still going to stay on grounding and bonding. And what we're going to do is we're going to look at 250.6, and we're going to look at objectionable current. Now, what we have here, this is just a start. This when you go through, I will tell you, I've seen the different grounding publications, everything out there. I will tell you, they're not going to get as in depth as what you're going to see in the design book that we have that goes through all the grounding and bonding. And
so, a question for you: is there anything in Article 100 that defines objectionable current?
No, not that I'm aware of.
Okay.
There's nothing that just says, there's not a definition of objectionable current. Let me put it that way.
It basically means that you're creating parallel paths.
That's exactly right. And if you look, we're just showing you here. We show you the utility, and then if you're looking on the right hand side of the illustration, you come down. We're showing where you got a parallel path of current, and we're just giving you an example here. We're just making something up. What would flow in this? Okay, so what we did is we tell you in note 1 we have a balanced current of 100 amps, and there's no current that's flowing on the neutral. Okay, now in note 2, we tell you current flow through the neutral could be as much as 95%.
Oh, Mike says we just started over at the beginning again or something. That's weird. Mike said, I don't know. It's weird.
He must have clicked off or something that did that.
Because it's still good. I'm streaming over here on mine. And
Yeah, I'm looking at our time here. It's still streaming. Yeah, the time's still going. I don't know. It shows us at almost 28 minutes. So,
yeah,
but anyway,
that's good.
we talk about the current flow through the neutral, and we take it could be as high as 95% and as low as 5% through the soil of the earth in most cases. Neutral current is 90% and earth current is 10%. Okay, so we're giving you basically the what you see out in the field, what type of readings you're gonna get. Okay, so if
okay, it's back. So thanks, Mike.
that must have been something on his.
Yeah.
Now we tell you here, we'll give you an example. So we say if you have 10% of unbalanced current returns through the ground, if I take 20 amps times 10%, that's going to give you 2 amps that flow through the ground, right?
Yes, sir.
Now, if I have a parallel path of current, which in this case is going to cause a parallel path, so therefore I'm going to have more current flowing through the neutral, you're going to see I'll take 20% at 90 amps, and then that's going to give you 18 amps of flow in the neutral conductor.
Woo.
Okay, so
you don't want that.
No, you don't. But what we're trying to point out here is you have to understand that you're picking up objectionable current over those grounding conductors. Okay,
Right.
so this is a rule of thumb method of what you're going to see when you're out there. So we always try to take when we get in and we start talking about. We'll look at 250.6 A through E, and we're trying to get you started here to understand what is objectionable current and how does it flow over the conductors. Okay, right. and how would you go about determining that, and what is the rule of thumb, and what type of current could you see flowing through that neutral? Well, as we tell you, it could be as high as 95% and as low as what? 5%. Okay, right. So we just took some values here to give you an idea. So if I look at that unbalanced current and I have 100 amps and let me put it this way, you're looking at your phase conductors, and if I have 100 amps on one phase and 80 amps on the other phase, what is that going to give me? 20 amps. That's why I'm using the 20 amps up there at 10% and 90%. That's where my 20 unbalanced current comes.
All right. Okay. Yeah, I have a funny story about this. I had one time they had one of these job site trailers out there, and they said, yeah, people are getting shocked off the trailer, off the ground of the trailer, And I'm like, okay, that's weird, And I was like, oh, is it plugged in a GFCI? They're like, oh yeah, it's in a GFCI. I'm like, wow. I was like, how are people getting shocked if it's our GFCI, And so then I get out there and I'm like, okay, well they don't got no ground rod, because typically that's first thing I do is drive a ground rod,
Sure.
So I go out there, drive a ground rod, I hook it up, GFCI trips. I'm like, okay, now we're getting somewhere,
That's right.
Like, all right. So I go and look, and there's this chassis ground. It's like a number 4 chassis ground that goes from the little trailer panel to the tongue of the trailer. And I shine my flashlight up in there, and they used some remodel bit in there, and they just went through like every single wire in there and ran that number 4 ground in there. And that's what I was doing it. So it was weird, because the first time, right when I drove that ground rod, I hooked it up and seen the breaker trip. I was like, all right, now I know what we got.
So you had all kinds of multiple points.
Yeah, it was mostly neutral, but it was the return pass that were tripping. Oh, David Englehart. Yeah, right on, sir. Thanks for coming in. I appreciate it. But yeah, it was funny, because there was some ungrounded conductors that were in contact, but it was such a mild contact that it wasn't opening any overcurrent devices,
Right.
but it was getting people shocked off the energized metal.
That's right. That's exactly right. All right. Now, when you go over in the first heading, you're going to pick up. Now, I will tell you this, that illustration we just looked at, that is just our own illustration to explain what's taking place. That's not something that you're looking in the text and it's telling you that. That's years and years of experience of what we've noticed through the grounding system of what you're going to see. So always remember, if you're trying to determine what that unbalanced current is, just get what the between the phases, and then you subtract from there. That'll tell you what the amperage is at that point that you're going to be able to determine what the unbalanced current is. Okay.
Yeah,
So,
and I want to do a little bit of a disclaimer on this because James, you have kind of the same habit I do because it either could be legs or phases. Because like if you're on single phase, then it would be A leg and B leg, and then if you're on three phase, it'd be like A phase and B phase.
sure.
So they're not always phases. They're sometimes if it's single phase, it'd be A leg and B leg.
Yeah. It just habit.
Yeah, no, I do it all the time. I just try to. I'm really bad at Luminaires. I'll say, yeah, no, over there at the lights. And like, you mean the Luminaires? So
That's
we're
like I
trying to.
was doing a class one time and I kept saying Romex. And one of the guys there, he goes, "What is Romex?" And I
It's
was
a
like,
brand name.
yeah, it's just a habit. It's what I've always called it. Uh,
Yeah.
it's like one time I was doing it and I was saying BX cable. There, one of the guys there, what's BX cable? I'm like,
Yeah.
you just don't even think about it.
I
So,
remember one time when the guy says, "What's a motor?"
yeah, that's when you're talking too fast. Okay. So when you look at 250.6a, this is where you get in and you start talking about the arrangement that you're going to use to prevent ejectable current. And what it tells you here, it says the grounding and bonding of electrical systems, circuit conductors, surge arresters, surge protection devices, and conducted normally non-current metal parts of equipment shall be installed and arranged in a manner that will prevent ejectable current. Now, this all goes back to where we started last week, and we were going over the very first and looking at 250.4, and I was talking about the general requirements there, and I always kept coming back saying everything needs to go back to where 1 point.
1 point. Yep.
Okay, so that's always when I'm teaching apprentices, journeymen. It doesn't matter who I'm teaching, engineers even. I always go through on the grounding system. And I said, you have to understand that when you're developing and designing that grounding system, you want to get everything back to that 1 point.
Right.
And because you don't want to have multiple paths and creating parallel paths. And I've ran into a lot of jobs that I've gone out to that they've had engineering staff out there. I remember I went and did one. I had to go to NASA. They were blowing some boards and stuff. And Jerry, that's there, he called me and said, "Hey, man, would you come down and take a look at this? We're having a lot of problems." And what had happened was they had come down and they had set a bar, and they were all their standing units. They brought them over to that bar. Well, then they went from that bar over to the grounding electrode system. Well,
Right.
what ended up happening, they were picking up from other stuff coming down that they tied into that. Well, that become the shortest path over to that mainframe. And guess what was happening? They were blowing them boards. And I told them, I took,
Oh, Wade.
hey,
Wade
wait.
Sexton in the house, sir. Right on. Thanks
So I had them
for
put
joining.
another bus bar there and
Mhm.
everything come into there. And then I took it over to the grounding electrode system. So everything come back to that 1 point to ground over there. And guess what? It cleared everything up just like that. And they had been out there working, had oscilloscopes and everything out there tracking these surges that were coming in, and they couldn't figure out how to get rid of it. And I showed up out there in 30 minutes. We had already fixed the problem. So, and I remember the engineers when I was telling them what to do, they go, "Hey, what are you doing?" And I was trying to explain it to them, but they didn't want to hear it because somebody come out and fix something in 30 minutes. And
I'm working on some high tech Siemens,
Mhm.
brand new technology. I mean, it's so brand new we can't even find it and can't even get it ordered and show up. But the big thing that they have is they have these bonding points on the panels,
Mhm.
and there's like 4 bonding points. And the first thing, if you call up tech support for a problem, first thing they'll ask you if you have all those bonding points connected.
Well, the reason they have the bonding points is there is to pick up any type of stray current and get it back to the equipment ground to take it back to the one point.
Yes, sir.
There's a lot of them that they do that with the equipment now just to make sure because they get this residual energy and everything across the equipment and they want to get it off of there. That's why they bond it off.
Right.
Okay.
Yes,
Now
sir.
this is a basic illustration, and we talk about here preventing ejectional current. And all we try to point out here is if you notice where I go even from the utility transformer, or I'm even looking at the service panel that's there, I've got one point that everything's going to come back to that service panel, and then that point there goes back to another point that's at the utility where they ground their transformer. And
Right.
that was something. There was some, I'm not going to say his name, but he said the utility grounds the system for
Right.
at the building or structure. And I said, nah, I said, that's a bunch of crap. That ain't correct. I said, you've got to come in and ground at your system there. And the
Yep.
reason that we do that is like we were looking last week in 250.4, and that's
Yep.
through the lightning strike surges or anything where you
Yes,
can
sir.
take it all back to one point at your service. Okay.
Yep. I
So
agree.
when you look at that, what is the first part of this to preventing ejectional current? Well, you're going to have grounding of your electrical system, your circuit conductor, surge arrestor, surge protective devices, basically anything that can carry any type of current is all going to come back to where? That one point. You see what
Right.
I'm saying? That's why this is set up. And when you come back and look at 250.6a, that's what it's telling you here. Okay.
I gotta get Wade in here with the metal reference. Ride the lightning, brother.
Ride the lightning.
Like it.
All right. Now, I like to look at 250.6b. I like to sort of refer to this as my troubleshooting. Okay.
Right.
Because these are your alterations to try to stop the ejectable current that you have on the system. So it tells you here if the use of multiple grounding and bonding connections result in ejectable current and the requirements, and looky here, it refers me right back to where 250.4A5, which is grounded systems, or
Yep.
B4, which is ungrounded systems, are met.
Right.
One or more of the following alterations shall be permitted. Okay. So they're telling you here that you can discontinue one or more, but not all of such grounding or bonding connections. You can
Right.
change the locations of the grounding or bonding connections. You can interrupt the continuity of the conductor or conductive path causing the ejectable current, or take other remedial or other approved action. Okay.
Right.
So what we like to show here is let's look at the system itself. Now, if I go over and I look at 250.50, all right. Now, one of the things it tells you if any of the grounding electrodes are present, you have to do what? Bond them in together.
Oh yeah.
Now, what?
Any and all available means to ground
Right
shall be
now,
used.
how many times have you seen on a job where they don't bond them all together?
Well,
That
I've
used
seen it.
that was common quite a while back. Now you don't see it as much. But if you
Mhm.
go to an older system, you might see this. Okay. So what you have to do is look at 250.50 and 52A1 through A7 talks about the different type of electrodes that are there. So I could be looking at this and say, all right, where am I picking up ejectionable current? Well, let's say that I come over and I'm looking at the transformer. Now you can see I can be on that supply side with the ground and then on that load side. Now that could be a place where I'm picking up some unwanted objectional current that would cause it to flow through where? The system.
So what you're saying is between those two, they are not common, or they are common at with.
No, they're not at one common point. That's what I'm trying to tell you.
So you're saying one's bonded to the transformer can, the other's bonded to the transformer can on the other side?
No, it's just upstream bonded somewhere. That's what I'm trying to tell you. It's an extra
Gotcha.
one that's there, and what it's causing, it's causing some unwanted objectional current through the system.
Well, you're
And
gonna get a voltage potential because of the difference of resistance that, and they're not connected.
sure you are. That's exactly right.
Yeah.
And that's why we put this illustration here. So this would be one where I'm going to do a process of elimination. So what I'm going to do is I'm going to go to that supply side there and I'm going to disconnect that ground there, and that'll probably clear up my objectional current problems. Okay.
Right.
But once again, that's the point where it talks about discontinuing one or more such grounding connections. You have to go through and figure out, where am I picking up this objectional current? I'll give you another example. This is just one illustration. We actually have another illustration where we get over and we start talking about equipment grounding conductors and stuff. But where we're dealing with like 250.146D, and you get in and you have isolated equipment grounds. Well, let me give you another example. Let's take that transformer, remove the transformer, and let's go over here. Instead, I put a panel board there, and I might do this. I might update this illustration and come off of this here and come over and add a panel board, see if I have enough room to do it, and put me a sub panel. All right. Now, if I put a sub panel and I'm within the same building and I come over to that sub panel and I hit my grounding electrode system, am I going to have a possibility where I'm going to create parallel paths within the system?
Absolutely.
Sure you are. So what would happen, I would remove that ground that's there on that sub panel. Now let's say that they come in, because I've actually seen this before, where they come in, they hit the equipment grounding terminal bar, and then they come back over to the main service equipment over here. Now all of a sudden, at that equipment grounding terminal bar there, I ran all my isolated equipment grounds there. Could that take and cause me a problem with ejectable current? Sure, because it's supposed to be an isolated one. So if what could happen if I'm picking up any stray current or anything, that could run back across where? That isolated equipment ground back to the equipment, because it's the closest path.
I think that the way you presented that really wasn't enough information, because basically your equipment ground is supposed to bond all the metal, and the isolated ground is supposed to touch nothing, touch no metal. So I mean, it's a potential for objectionable current, but not unless, if you do it correctly, it's not. But if you do it incorrectly, then yeah,
that's right.
You're
and
correct.
That's what I'm saying. It depends how that system's set up, and that's what I'm saying. If I go over a sub panel and you've got to run over there, say it's 100 foot, whatever, and then all of a sudden you come in, you've got all these isolated equipment grounds, and you tie those into the equipment grounding bar instead of an isolated equipment grounding bar. Now you've got a problem. So
because that's the whole point of an isolated bar.
That's right. And when you have that isolation and you take it back to that service equipment, I'm taking it all back to where? One point. You see what I'm saying? So that's what 250.6B is when we're dealing with the alterations to a stop ejectable current. You have to look at the locations of those grounding connections, and you may have to interrupt the continuity of that conductor or conductive path that's causing that ejectionable current. So therefore, I would have to put it as an example for the sub panel. I'd have to have an isolated equipment grounding terminal bar there that isolates back to that service equipment. I think I'll try to see if I can adjust that illustration and add that in there with that transformer. I think that would be a really good one to look at.
Yeah, I agree.
See, that's one reason I like doing some of these when you're explaining it, because sometimes you can add something to the illustration to go a little further in depth.
Yeah, I agree. Yeah, and that's like a separately derived system. So
Right. Now, the next one is going to talk about where you have currents where they're not classified as objectional currents. So this is where you have currents that are resulting from abnormal conditions, and this is going to be items such as ground faults and from currents resulting from required grounding and bonding connections shall not be classified as objectionable current for the purposes that we just looked at in 250.6 A and B. Okay, so when I look at this, what they're talking about here is when you look at a system, it's set up here. Now, one of the things I like to point out, you'll see there at the transformer, you'll see we talk about temporary current flow. And you'll see we're showing it on the load side of that transformer there. And then we're coming down and showing where I would have a phase that got accidentally grounded. What's going to happen there? You're going to get an accidental ground there. That is what they're talking about. Now, you also look at that. We also show the neutral and equipment ground. And what we're trying to show there is that you can have currents through all three of those that are resulting from an accidental connection or condition, shall I say, a condition that takes place, and that could be due to a what? A ground fault. Okay. And that, but when that happens, that's okay because those grounding conductors are performing what? Their intended protective function. Therefore, since that's the case, that's not considered what? Objectional current.
okay.
Okay. Now, the reason they do that, because some will look at that and they had to, I remember when they did this, they went in and they put this in there to talk about these temporary currents because they wanted to make absolutely sure you understood if you have a ground fault, that's not objectional current. Okay.
Right.
That's how it's intended to operate in order to clear that overcurrent device.
Gotcha.
Right?
Okay.
Now,
So would that be like a open delta transformer or something?
no, it's just an equipment ground. When you go
Okay.
back, this is where you get a ground fault. If I could get it from the phase, I could get it from the neutral, the equipment ground. They're basically saying that current that's flowing across there, that's what it's intended to do. So therefore, it is not an objectional current. It's in
Okay.
there because you get a ground fault, and that's to facilitate the fault current path back in order to trip what? The overcurrent protection device. And that ties in with 250.4A5, where it talks about the effective ground fault current path. And therefore, it's not objectional current.
Isn't there like a delta that actually energizes the equipment ground or
Yeah, but
energizes the neutral?
yeah, but that has nothing to do with 250.6C.
Okay,
What they're
gotcha.
talking about here, they're just talking about a temporary current here where you get a ground fault that's not objectional current.
Okay,
You know what I'm
gotcha.
saying?
So it has current, but it's not technically a violation.
Right.
Okay,
Now,
I got you.
when you look at 250.6D, this is where you get to the limitations to permissible alterations. Now, what it tells you here, this section shall not be considered as permitting, now watch this, electronic equipment to be operated on the AC systems or branch circuits that are not connected to an equipment grounding conductor as required by this article. Currents that introduce electromagnetic interference or data errors in electronic equipment shall not be considered objectionable current addressed in this section. Okay. And that's what you were talking about the equipment a while ago, where they ask you if they had all the bonds in and everything. They realize that equipment has this objectionable current there. Now, I don't want to say objectionable current, I want to call it residual current that's on that system. So they're bonding it all in order to get that off and not create any electromagnetic interference in that electronic equipment. You see what I'm
Right.
saying?
Yeah.
Now, when you get into that, here's a good example. How would I go about that? Well, what would happen is, say I'm running EMT over to that equipment and I've got a mainframe over there. What you're going to do, if you go look at 250.96B, and this also ties in with if I come off and I have uh, an isolated equipment grounding conductor over there looking at 251.46D. But what they try to do to keep from having any residual current coming from any other type systems, they'll come in and put a non-metallic spacer there, and that's a limitation uh, for that equipment. So that's why they bond all that in. So what I tell people, if you're picking up something from somewhere in the facility, it could be something as simple as coming in and rewiring this thing and putting a non-metallic spacer in, and that'll keep any outside influences that are coming across those conduits or anything from entering that sensitive electronic equipment.
Hey, so question, could you do that same thing with the ferrite choke?
With a what?
With a ferrite choke where you wrap the hot conductor with the ferrite choke?
I guess you could. I don't know why you couldn't.
Okay.
Because what you're doing, you're trying to limit um, any objectionable current or anything that can come across the system back into that equipment. So therefore, I'd say sure. I don't know why you wouldn't.
Okay. I got you.
Have you run into that before where you were picking
Yeah.
something up?
Yeah, like we've never had to like dig the concrete up and put non-metallic spacer in there, but we always just use ferrite choke, I think. But I
Okay.
thought that's that they were for, but not
Well,
sure.
you got to remember when you're looking at it, you're sometimes, depending on the type of equipment, you're trying to make an alteration to it. And
Right.
that's what you're looking at here. And this is a good example of one why we're saying you look at that sensitive electronic equipment, we realize how that is designed there, and we don't want to pick any stray currents up because it becomes the closest path to ground. Therefore, we would just put a non-metallic spacer there, and that would eliminate that. You
Dude,
just
I'm just glad you got Pops a new computer for the illustration.
actually, I'm redrawing all these. This is the grounding chapter,
Okay.
and everything is being updated in high level. I mean, it's I'm really impressed at the way the new illustrations are coming out, and
Nice.
I like
I like
all the coloring, everything. I mean,
Yeah.
it it's it looks like what you would see out in the field. You know what I
Yeah.
mean?
That sure looks like freaking a Node 2 over at my job site.
Sure. Now, the last thing that you have is where it talks about isolation of objectionable direct current from a cathodic protection system. All right. And they'll tell you here if isolation of objectionable direct current from a cathodic protection system is required, they won't hear a listed isolator device shall be permitted in the equipment grounding path to provide an effective return path for the AC ground fault current while blocking the flow of direct currents. Okay. So basically, what you're getting into here is you'll look up here and you'll see right here at the bottom of the illustration, we show you a DC isolator AC coupler that's put in here. And basically, what that's doing, that's isolating that direct current. Okay.
Right.
In order for the equipment path to get back and all that. So,
Okay.
that's basically what you're getting into when you take and you look at your different things for objectionable current and what's permitted. Now, I will say this when I'm telling people to look at this, you really should automatically know C and D. You shouldn't
Right.
have to really, get into that much. But A and B is where you really need to know because A talks about basically the objectionable current and getting it back to where 1 point. B is where I get in and I start doing the troubleshooting, and it gives you the options of things that you're going to look at in order to get rid of any objectionable current on the system. And once
Right.
you know that, 250.6 is not hard to understand. And that's what I always tell everybody. You just got to know what you're looking at and how it has been.
Oh, lost you for a second. Oh, you froze. You're in freeze mode. Freeze. No. James froze. That's so funny, Wade. Yeah, he's like, oh man, let's talk up freeze. He'll be back on here in a second. Oh, there he goes. Oh, is he back? Up, is he back? Up, 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 up. There he is.
Oh, my system just shut down. I don't know what the hell happened. It just
Dude, Wade says the CIA said, screw your objectionable energy.
I guess so. Somebody's pissed off about me teaching it. And it just shut down. I was like, what the hell happened? Oh well.
Yeah, there's been times when it's happened to me, and I just got home from work. I didn't even know what was going on. You're like, oh, Bill finally made it.
There we go. I'm back. Hopefully I'm back.
All right.
Golly, that was unbelievable. I mean, it just shut down. I was like, what the hell? I never had that happen before.
Yeah, it did it to me. Did it? I just froze up.
Really? Yeah, it just went boom. I was like, what the hell? Are we under martial law already? Like, what's going on?
Dude, I'm telling you, dude, they're just mad that they have to wait till December to lock up Trump. So
I guess we'll see. Man, that just I've never had that happen before. Oh well.
All right.
All right, you ready for your tool?
Let's do it.
All right.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right. So my tool this week is pretty simple. It's just a screwdriver. I actually just bought it to check it out and see how it works. But it's a DeWalt extendable screwdriver. I kind of like it. I used it today just to mess around, see how it works. It seems like it works pretty good. It's just basically got a drill chuck in it, and it's just basically like a screwdriver. I didn't really like that there was nowhere to really store the bits, because I thought that the back came off and you could like store them somewhere, but it didn't. So that was kind of a downfall that I thought about it. But I was able to, set it up pretty good for just straighten the Phillips and, do whatever I needed to do. It's got the ratcheting feature, which I kind of like. And you don't see in this picture, but it could extend out 3 times. If I go over to here, you can see it like extends out. So, you can go back to whatever you want to set up for that cabinet, or whatnot. But it seemed to work out good for me. Like I say, I try to switch off DeWalt, Milwaukee, everything like that. But like I say, overall, it was a decent screwdriver. Like I say, I'm trying not to do anything too crazy as far as my reviews. But like I say, it's for a screwdriver, works really good. And then Wade says, yeah, yeah, yeah. That's pretty funny, Wade. Wade is a big time Milwaukee guy, so we'll be going back and forth, giving each other a hard time. So.
That's funny. Give me a fat Wade.
Yep. But like it. No, so it's just one of my things that I'm gonna be doing, just kind of back and forth. I might do like a Milwaukee one next week, just to show me. I might even try out a Milwaukee one, see how it works for me. See if maybe the features are better or whatnot. maybe it has more things sliding into it. Who knows? You know.
Okay. All right. So
Yeah. So awesome. Um. Is there any more slides left on the thing?
oh shoot. Question of the week.
What?
What do you got this week? Let's see. All right. Let me read
Oh,
it.
don't forget to put up the banner.
Let's see. Minimum initial standard size. Okay. Uh, maximum branch circuit, short circuit ground fault for 5 horsepower, 240 volts phase AC continuous duty motor with no code letter indicator. Okay. I think for a 5 horsepower, 240 volt single phase, let me look. I think it's 28 amps. I need to look at my code book just to be sure.
Okay.
Give me a
Yeah,
second.
you have plenty of time here. Since you made the podcast, we gave you a limited time to figure these out.
I'm looking.
Yeah, and like when I saw this, I thought, you know what? I bet you, James
Okay.
I might actually get you on this one.
Okay. It was 28 amps. Okay.
Yeah,
So you're doing a non-time delay fuse.
yeah,
Okay. So I'm going to look at 430.52C1, which is going to refer me to table 430.52. That's going to be 300%. Let me get my phone out here. Let me calculate this. Let's see. 28. Give me 1 second here. Yeah, you got me in a calculation. I can't just do that on the top of
Hey,
my head.
like I say, this was actually on the Colorado exam, so I figure probably a pretty good one.
Okay, so that's going to give me 84 amps. Your answer is going to be C.
That's not what the book said. The book said the answer was D. And if you look at our NEC question of the week, we have first place Kyle Dodge, second place Shane Goods, and third place Mike Callan. And I'm not sure if this question is right or not.
It's not.
But
Uh, let me explain it. Okay, if and everybody can follow along with this. All right, now
mhm.
if I go look, I'll just lay it out. Now,
It said in the book to go to the next standard size from 84. So it said to go to 84 to 90 because that's your next standard size.
well, now if you're going to neck size, it's 90 amp, but that's not what you asked.
Well, and like I say, it says what is the maximum.
Okay, I'm gonna go through and explain this. Okay.
Okay, gotcha.
Now, if I go and where all of it starts, if and I'll give everybody a code loop here, and y'all can follow and see if you agree with me. If I
Okay.
go look at 240.4G, when you go over there, you're going to pick up the heading there. It's going to be specific conductor applications, and 240.4G is where it's going to tell you motors and motor circuit conductors, and it's going to tell you go to Article 430 and see all these parts. Okay. Now, if I start right at Article 430 and I pick up 430.6A1, that's where you're going to pick up where it's going to tell you anytime you're sizing your overcurrent device or your conductors, you're going to use one of the tables listed in 430.247 through 250. And then
Right.
you're, in this case, since that was single phase, you're going to go to table 430.248 and you'll come down and you're going to pick up the 230 volt column and come down, pick up 5 horsepower. That's going to tell you it's good for 28 amps. Okay. Now, at
Right.
that point, nobody's going to disagree.
Right.
Okay. Now, the next thing I have to do is size my overcurrent device. Now, what I always tell everybody, if you're going through your code book and you're trying to remember where to go back and everything, right there at that table 430, 248, and 250, always I have them put sizing OCPD, and then I'll have them put a little bullet under it, and I'll say 430.52C1 and table 430.52C1. And then if I'm sizing conductors, I'll tell them to go to 430.22 and 430.24. But since we're doing the overcurrent device, I'm going to go look first and foremost at 430.52 C1, and that heading is going to say in accordance with table 430.52C1. And what it's going to tell you is that overcurrent device has to have a rating or setting, and I'm paraphrasing what it says here, not exceeding the value that's calculated to the percentages that are given in where? Table 430.52C1. Okay.
Right.
And it tells you it shall be used unless what? Otherwise permitted in 430.52C1A or B. Okay. That used to be exception 1 and exception 2. Okay. Or exception 1, exception 2. Now, if I look at that and I take the 28 amps and we're doing a non-time delay fuse, I come down, it's going to tell you it's 300% in that table. Now, what it says in 430.52C1, it says an overcurrent device that has a rating or seating not what? Exceeding the value calculated according to the value. Now, if I can't exceed it, then I have to do what? Drop down. Now, your question stated the initial maximum size. Well, if you look at the table, and our publications, we do it a little bit different, but it says maximum rating or setting. That's the maximum for that table. That's not the maximum size. You see what I'm saying? We call it the minimum size. You got to have a starting point. Okay.
Right.
So that is why we calculated 83 amps, and the next size below that is what? 80 amps.
But one thing that we want to tell everyone out there that me and James kind of ran across, actually James ran across it. I just act like I did it. But we have a thumb rule where if your percentage is over 125%, you drop down to the next standard size. And if your percentage is 125% or lower, you go up to the next standard size.
That's correct. The only time you're going to find that in the code where that rule does not follow is if you go look at 455.7B2 and you're dealing with conversion, your phase conversion, it tells you have to protect the conductor. So therefore, you're going to go up to the next standard size. And then transformers in table 450.3A and B, there will be note 1. It'll say C note 1, C note 1 on a lot of them. And it gives you the option to drop down or go up to the next standard size. Okay, because it says shall be permitted. It doesn't say shall. And that's what I always tell everybody. You got to look at what's in there and apply the wording. And if I can go look at all other different types of overcurrent devices for like AC units, it'll tell you it can't exceed the value. Same thing if I go over deal with welders. I mean, I could just go on and on with this stuff. But I stick with what the wording says. So 430.52C1 specifically says shall not exceed the value calculated. Okay.
Nice.
So
now, you blew this one up.
I'm not done.
Like I said.
Okay. Now, right after that, if you look at 430.52 C1A, it tells you without doing any further calculation, you're automatically permitted to go up to the next standard size, which would be a 90 amp.
Okay.
See that? Now, then it tells me I can take after that, and if I'm looking at sizing the non-time delay fuse, if I look at B1, 430.52C1B1, it tells me I can take that 28 amps at 400%. Now, this is where we say the maximum size. Now, that'll give you 112 amps. The next size below that is 110.
Okay.
So that's why.
So there might have been somebody out there that said 110. You're technically right. And if you said E, right?
Well, the way you have it written there, you say the maximum initial standard size. So the initial is when you start the calculation at the initial percentage, which is 300%. So therefore, I would say this answer should be C.
Okay.
That's my
opinion. Right. Well, you know what? I'm going to go ahead and I'm going to have two right answers, 80 and 90. The book that I had said D was the right answer, 90. All the people in the banner down below answered 90, and per the book, it said you're right. But I will have to give King James the win on this one. He did the thumb rule correctly and dropped down to the next standard size, which is 80 amps. So
Well, if if you look at the wording that's there, and that's why I always tell everybody, just go look at it and see what it says, and then decide that. Now, if I was not to make, well,
yeah.
I tell you, I've been doing this a long time, and I've heard so many questions, answers, everything. And I actually had to calculate. I just didn't know that off the top of my head like that, but. Uh,
We give King James the whole entire floor when it comes to calculation. And what's funny about it is everyone learns, and I can guarantee you, have a bunch of people reaching out to me like, "Hey, did you see how fast he went through all them tables?" And yeah, I can even keep up my code book. I had to pause 7 times, But it's really awesome. It's truly an honor to be doing this with you, James, and I love doing it every week. It's a lot of fun, and we get to give each other crap. I really apologize. I shouldn't have bagged on you so hard about the belt buckle and about the stars, because it looks like we might be playing the stars in the playoffs, and you know. I don't know if you looked at who's first right now, but it ain't the Stars.
They're not. I hadn't looked. I hadn't
Yeah.
kept up with anything. I'm busting my ass around here trying to get everything done and get everything back up and running. And uh, I'm telling everybody when they
That's a funny one, Wade.
yes, well, I always tell people, when I'm uh, doing like the code question of the week and stuff like that, and I do the topic of the week and everything that I'm showing and all that information is going to be in the our publications, or it'll be in the new online courses, and you can pick all that information up. We go through and fully explain everything I'm telling you, and we have a lot of tips in our publications of things that you need to look for. You're looking at a combined 80 years experience between Dad and I, if not more. Um, and we've been to some of the biggest companies in the world fixing problems for them. We've seen stuff people have never seen, and we've been in places people just don't get to go. Research laboratories and stuff like that, and uh, you actually learn a lot when you're out in these type of fields, and we try to pass that information on, so when people get out there, they know what they're looking for. And
So I have this really funny story. I was in this research lab, and what they have is they have all these different alarms that go off for
mhm,
like if their experiment gets below a certain temperature, or
sure,
like if they do something different with the air or whatever, and they have all these alarms going off like all day. That's all you're hearing is all these alarms.
hmm
And then all of a sudden I look over and I see the fire alarm going off, and I'm like, I kind of like, it was weird because I was like, man, am I supposed to pay attention to that? Because like I just been hearing all these alarms all day, and then I look over at the head scientist guy, and he's like, "Fire, get out," and I just felt so stupid because I'm like, I just been ignoring all these alarms all day. You know what I mean? I'm like, yeah, you would think that that's the first thing. I'm going to fix their fire alarm or whatever. Like, yeah, I should probably get out because it's like set off the fire alarm, and then it was funny because the fire department was like questioning me like I set it off,
yeah.
because I was like the last person out, and they're like, "What are you doing?" And I was like, "What do you mean?" They're like, "Well, how did it go off?" I was like, "I don't know." And they're like, "Aren't you here to fix fire alarm?" I was like, "Well, yeah, but I don't know what set it off." And it was just funny, and they're like, "Well, surely it had to be something," and I was like, "Well, yeah, it had to be something," but I was like, "Do you have
What
anything on the
me?
graphic? Yeah, do you have anything on the graphic map?" And then we started going through, and I started showing them how to go into the history of the fire alarm and see like what actual device triggered it, and we figured out like where it actually came from, what device it was, and you know what I mean. Like we figured it out what it was. It was some experiment or something that
Right.
like let off some smoke or something. But it was funny because it was like I was just so I couldn't get acclimated to that environment of
Mm-hmm.
just getting in there and just all these alarms going off, and like if you're trying to find a problem, you know what I mean, it's just all this stuff's happening, you know what I mean. And the biggest thing you can't do there, I learned, is you cannot kill power. Like you pull up with an electrical van to one of those places, they're like, "Oh hell no!" They're like,
Mm-hmm.
"You're not even walking in this building." And I'm like, "Why?" They're like, "You're gonna kill power." You know, I'm like, "No, I'm not." You know. And then next thing you know, I'm like tracing a circuit or whatever, and then they're just like looking at me like, "Oh man, what are you doing? What are you doing?" "Well, I'm tracing a circuit." "Don't kill it! Don't kill it!" You know. And
Yeah.
some of these people, they have experiments that take like 2 weeks to set up, and if you take a ceiling tile out and get some ceiling tile dust in their little experiment, then it turns it into some kind of weird different experiment that's not even close to what they're trying to do.
Sure.
So it's cool. That's how we learn and these kind of things. I always like doing these live streams and just kind of sharing you guys a bunch of war stories, stuff I've been through, and just
Well, sure.
kind of relating it to code and busting some myths. But
Yeah. Uh, I don't know how many shows we're at, but we've been doing it for a whole year, and we still
yeah,
got tons more to do. So it
yeah.
is so
What was
short.
the one we were thinking for next week? I remember when I was coming home, I was like, what was that we were talking about for the next week myth? It's like, oh yeah, that's a good one.
I don't
But
remember. I've had so
we
many things run through my mind.
yeah, like we come across so many, but I'm sure we'll figure it out next week. Everyone will be surprised, and I really appreciate everyone participating tonight. It's been a real joy for me, real joy for Nat King Code, and to get the question of the week out there. And dude, the way you put it together is really awesome, and I kind of like my little graphic with Homer with the whole fire going on behind him. Oh, cool! Let's check out the code question of the week.
Yeah, that's one of the things. Uh, I when I'm putting stuff together, I'm doing it super quick. I don't even really look at what's there. I'm just boom, 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 get it done. Because I got other things that are on my mind. I got to get completed, and
I always like sneaking that little slide in. It takes you a minute to kind of adjust to it, but you know.
well, I've been doing it a long time. That, and I actually had to look up and get the values. So I just didn't know all. Nobody can remember every value in those tables. There's no way. I did get it, but I was guessing. That's why I was like, I need to look this up. I think it's
Dude,
20.
I'm telling you, the stall cup right answer is C. So you know what? I mean, I'm gonna have to go in there and pencil that one in the book and get it right. So
The way it reads, I think it's C. So, and I gave my reasoning behind it and showed the calculation and all the values I come up with and explained how you size that overcurrent device. So, the ones that answered 90, you could go ahead and tell them I don't agree with them.
yeah, that's so funny. Yeah, like it's really awesome. I mean, like I say, I've been doing fire alarm for quite a long time, but like I say, off and on, I've done electrical service. I built one line. I've done gas and oil. Done a million things, and I'm always trying to challenge myself to do something better, do something bigger, better.
Well, always.
Yep.
Everybody is.
But
All right.
thanks everyone for joining. Appreciate you, Wade, coming by. Appreciate David Englehart popping in. Appreciate Mark Candel's coming by. Awesome. Mike Wilson, thanks for coming in. Mike Barr, awesome having you, sir. And it's just been awesome to have all the community of code people out there that we get to share these with and kind of talk some code, get a little nerded out, talk shop after work, and just have some fun.
Yeah.
So
We'll have another one coming next week. It just, uh, I sort of enjoy doing the grounding and bonding, because
yeah.
I don't really see anybody that gets in depth and starts from the first and gets in the next part. Why? And if you notice, I've tied everything back to where 1 point.
1 point. Yeah.
I always do, and I always teach that. And I never see anybody teach grounding and bonding that way. You know, and
Well, it's really truly an honor to be part of the Stall Cups, and like I say, I won't go into all the names that they call me, but when the Stall Cups talk, people listen.
EF Hutton, baby.
I know, right?
I wished.
I know.
Everybody's like, I ain't listen to that asshole.
Awesome. Well, we'll go ahead and get out of here. Let you go get some dinner. I'm sure Pops is probably over there getting ready to turn the lights off on you.
Yeah, he's actually over there. He wants to go eat. He's like, let's go eat tonight. I was like, okay. He's in the process. He's been updating the 70B publication, and I will tell you, it's a brand new book. Everything has been relayed out, and when he finishes that, and he knows exactly what's took place, we're actually going to have him on to explain what took place in 70B, because that's now going to be recognized. It's not recommended anymore. So
it's an adopted standard.
That's right. It's going to be very important for people to have an understanding of what took place, because they need to understand the maintenance requirements and everything. So,
oh, dude, thanks for joining us, Mike.
hey, thanks, Mike. Appreciate it.
We'll have you on, sir.
You're about to be on pretty soon, brother. Probably in a couple of weeks, and
we'll get something dialed in for the high voltage side.
Yeah, you couldn't have anybody better than Mike Barr on the high voltage side. I mean,
dude, that little thing that he had where he was like doing the dead lineman thing.
Oh yeah,
with the audible thing, like that was awesome, man. He made his own little thing.
Yeah, he's got it all set up behind him. He's got two different models set up behind him where he goes through and shows it all. I mean, that's kick ass. I mean, you just don't get that kind of stuff on awesome. Live video. I mean, that's freaking awesome.
But I'm getting ready to go watch the Avalanche beat up on the San Jose Sharks, and go Avs. Congratulations, clinching the playoffs. If you guys want to follow my page on Facebook, on my group on Facebook, it's Avalanche Alley, and we are going to go win another Stanley Cup.
Has Dallas clinched?
Not yet. They might have. I'm not sure, but it's all tied up right now. Like pretty much between Dallas, Minnesota, and Colorado, it's all like neck and neck. So.
Oh, really?
We don't know. We don't know who's going to take first. Like, I know we're a little bit ahead of Dallas. We were ahead by like 3 points, but I think we're only 1 point behind Minnesota now, but it's just all neck and neck. So I think if we win tonight, I think we could take Minnesota, but I'm not sure. If Minnesota wins, I think they'll stay ahead of us, but it's hard to say because I think Minnesota has a pretty tough one tonight. So we'll see. We'll see how it all pans out, but it's a lot of fun, and I'm down for taking bets if Avs go against Stars first round. So
one of my good friends, Bill Joel, goes up to Pool Hall with us. We used to bowl together and all that. He's a big Stars fan. I'm a huge fan, and sure thing, Mike. And
awesome.
He's all into hockey, and I just. I don't know much about it. I only watch when it's playoff times, really, and that's if I have time. But the only thing I ever really take the time out is when the Longhorns are playing football and the Cowboys are playing football. I'm watching those games. Other than that, I just don't really watch much else. So
yeah, I can't wait for playoffs. I think it's gonna be awesome. Check out on the Avalanche Alley. We should have some links to some guys doing some brackets because we're going to try to do brackets this year and get everyone's bracket in.
That'll be cool.
And try to see who can dethrone me, I've never done it. So I'm basically like a rookie. So I've done it before, but I never got even close. Like I think all my teams got eliminated like first round. So, I went to like first base before. So I'm gonna try to get to like second or third this time, or maybe even get into the Stanley Cup. But that's the thing. I would have picked the Avs to go the whole way last season, and then I didn't even play, and then the Avs went all the way and won. So I always mess myself up at the end, but
Oh well.
we'll see.
All right.
But we'll go ahead and wrap this thing up. And remember, everyone, make every day an easy day.
See y'all next week, guys.
Deuces.